Good day, viewers and subscribers of DepEd tele-turuan. This is Sir Leoneil Castro or Sir Neil, a mathematics teacher from Lazaro Francisco Integrated School. I will be your math teacher for this episode, and we will study the lessons for Quarter 2, Week 2 in Mathematics 8 with the topic solving problems involving linear inequalities in two variables and solving problems involving systems of linear inequalities in two variables. Join me as we once again look at the beauty, discover the wonders, and appreciate the value of mathematics. In this episode, we will have the following learning objectives. First, translates verbal sentences into linear inequalities in two variables. And second, solves problems involving linear inequalities in two variables and system of linear inequalities in two variables. We will apply the concept of linear inequalities in two variables in real-life situations. That would be fun. First, let us recall some important concepts about the graph and solution of linear inequalities in two variables. The graph of a linear inequality in two variables is a half plane, and the solutions are all points on the shaded region of the graph. If the plane divider is a dashed line, points on the line are not part of the solution set. But if it is a solid line, the points on the line are also part of the solution set. Let us try these examples. The graph of 2x minus y is greater than 4 is shown on the screen. Is 6, 3 part of the solution set? Yes, very good. 6, 3 is part of the solution set since it is on the shaded region of the graph. How about negative 5, 1? Correct. It is not part of the solution set. If you substitute negative 5, 1 to 2x minus y is greater than 4, it will not satisfy the inequality. Is 5 negative 4 a solution? Great! Negative 5, 4 is on the shaded region of the graph, therefore it is a solution. If you want to be sure, you can substitute x and y in the inequality and you will see that the ordered pair satisfies the inequality. Application of mathematical concepts in real-life situations involves problem solving. In problem solving, there are no definite steps or way applicable to all problems. But I will give you some tips to make problem solving much easier. First, analyze the problem. Understanding the problem is very important in solving word problems. Next, translate the verbal sentences into equations and in this case, inequalities. Then, solve the inequality or equation formed using, of course, the appropriate method. And lastly, check your answer if it satisfies the condition in the problem. Are you ready to solve some problems now? Let us look in this first example. The entrance fee at BL Resort in Cabanatuan City cost 100 pesos for an adult and 80 pesos for a child. How many adults and children must enter the resort for them to earn at least 6,000 pesos a day? Give at least two possible answers. Since inequalities have infinite number of solutions, we cannot give all the solution to the problem. Analyze. The entrance fee in the resort is 100 pesos for an adult and 80 pesos for a child. We need to know how many adults and children must enter the resort for them to earn at least 6,000 in a day. The word at least suggests that we are dealing here with inequality. Translate and write. If we let x be the number of adults entering the resort and y the number of children entering the resort, we can now write the inequality. Since the entrance fee is 100 pesos per adult, that would translate to 100x. And for children, that is 80y. The symbol of at least is greater than or equal to. So the resulting inequality is 100x plus 80y is greater than or equal to 6,000. Now we have written the inequality representing the condition in the problem. Solve. This time we will solve the inequality 100x plus 80y is greater than or equal to 6,000 by graphing. First, replace the inequality symbol by an equal sign. 100x plus 80y is equal to 6,000. Graph the line using any method. We will use the intercept method in this example. Solving for the x-intercept, we have the x-intercept at 60, 0, and the y-intercept is at 0, 75. Plot it on the Cartesian plane and draw the plane divider. We have a solid line as plane divider since the symbol is greater than or equal to. Next, we choose a test point. Let us use 2020. Substituting the values of x and y in the inequality by the ordered pair 2020, we have 100 times 20 plus 80 times 20 is greater than or equal to 6,000. So 2,000 plus 1,600 is greater than or equal to 6,000. 2,000 plus 1,600 is 3,600. Is that greater than to 6,000? Does it satisfy the inequality? No. That means the shaded part of the graph is the half plane that do not contain 2020. This is now the graph of 100x plus 80y is greater than or equal to 6,000. All points in the shaded region are part of the solution set. But since we are talking about number of persons in this problem, we cannot have a negative number as a solution. We will get solutions from the first quadrant like 60-20 and 40-50. Since 60-20 and 40-50 are part of the solution set, the resort will earn at least 6,000 in a day if there will be 60 adults and 20 children or 40 adults and 50 children entering the resort. There are other possible answers in the problem, so your answers may vary. Again, to check your answers, substitute the value of x and y in the inequality with the ordered pair and see if it satisfies the given inequality. Easy, right? Let us look at another example. A cup of milk supplies 300 milligrams of calcium and an ounce of cheddar cheese supplies 200 milligrams of calcium. How many cups of milk and ounces of cheddar cheese is needed to meet the minimum requirement of 1,200 milligrams of calcium per day our body needs? Analyze. A cup of milk is equal to 300 milligrams of calcium. An ounce of cheddar cheese is equal to 200 milligrams of calcium. We need 1,200 milligrams of calcium on the minimum per day. Minimum means greater than or equal to. Translate and write. Let x be the number of cups of milk and y be the number of ounces of cheddar cheese. We can now write the inequality. A cup of milk is equal to 300 milligrams of calcium. So that is 300x. And an ounce of cheese is 200 milligrams of calcium. So that translates to 200y. The inequality is 300x plus 200y is greater than or equal to 1,200 since we need at least 1,200 milligrams of calcium a day. Let us solve. Replace the symbol in 300x plus 200y is greater than or equal to 1,200 by an equal sign. So we have 300x plus 200y is equal to 1,200. We get its intercept, so we can graph the line. The x-intercept is at 4, 0, and the y-intercept is at 0, 6. Did you get the same intercepts? Plotting it on the Cartesian plane and drawing the plane divider, then identifying the half plane that contains the solutions, we have this graph. We can now identify solutions. Looking at the graph, we can see many possible solutions. 5, 1, 3, 4, and 1, 7 are all part of the solution set. Some of the possible answers to the problems are 5 cups of milk plus 1 ounce of cheese, 3 cups of milk plus 4 ounces of cheese, 1 cup of milk plus 7 ounces of cheese. This will all give us the minimum required milligram of calcium needed by our body. There are many other possible answers, but remember, negative numbers are not acceptable answers since there are no negative number of cups or ounces. Another example. Mrs. Burgos wants to buy at least 30 kilos of pork and beef for her restaurant business but can spend no more than 12,000 pesos. A kilo of pork costs 240 pesos and the kilo of beef costs 300 pesos. Give at least 2 possible number of kilo of pork and beef Mrs. Burgos can buy. If we analyze this problem carefully, you will notice that there will be 2 inequalities involved. There are 2 conditions to be met. This type of problem involves system of linear inequalities in 2 variables. Now, we will pause for a break and we will return on that later.